You were given that f of x is equal to 2x minus 5 times x minus 1 times x minus 4. Part A says to sketch the graph of f of x. So I can see that he's going to have roots. It is going to equal 0 if x is 2.5 or 5 over 2. Or if x is 1. Or if x is 4. I can also see that it is going to intersect on the y-axis when x is 0. So if I make x 0 here, here and here, then I'm just going to get minus 5 times minus 1 times minus 4, which gives minus 20. Now, in terms of the shape, if I were to expand all of this out, I would end up with a positive 2x cubed. So my graph is going to start going up. It's going to pass through at 1, back down through at 5 over 2, and then up again through 4. So there's my sketch of f of x. Part B says to show that f of x is 2x cubed minus 15x squared plus 33x minus 20. So I just need to expand these brackets and hopefully show I get this. So let's do this. Let's expand the x minus 1 times the x minus 4 first. And let's leave the 2x minus 5 by itself for now. So x times x is x squared. X times the minus 4 is minus 4x. Minus 1 times x is minus 1x. And the minus 1 times the 4 is plus 4. You can then see that we can collect together those two terms in the middle there to be minus 5x. Now to multiply all of this by the 2x and the minus 5. So 2x times x squared is 2x cubed. 2x times the minus 5x is minus 10x squared. 2x times the 4 is 8x. Now we have the minus 5 times the x squared is minus 5x squared. Now we have the minus 5 times the minus 5x, which is going to be plus 25x. And then finally the minus 5 times the 4. Collecting like terms together then, so we've got the 2x cubed by itself, but then we have the minus 10x squared minus the 5x squared is minus 15x squared. The 8x plus the 25x is 33x, and we have the minus 20. And that is what we needed to show. So that's part B of this question done. Right, part II. You are given that g of x is equal to 2x cubed minus 15x squared plus 33x minus 40. Now, immediately before I look anywhere further, that should be hopefully ringing some bells for you. This seems familiar. In fact, it's very familiar. The 2x cubes are the same, the minus 15x squared are the same, the 33x's are the same. The only thing different is this one is minus 40 instead of minus 20. So straight away I'm thinking that g of x is equal to f of x just minus 20. This is the same thing as this minus 20. If I take 20 away from this, I get this. So what's happening here is we've got the graph that we've just drawn in part A minus 20 in the y direction. So I could just take my graph here. Imagine taking the graph we've drawn here and moving it down 20 so it cuts through at minus 40 on the y-axis instead. Anyway, we might come back to that later in the question. Just something to note at this stage. Right, part A, we need to show that g of 5 is equal to 0. So let's substitute 5 into our function. G of 5 equals 2 times 5 cubed minus 15 times 5 squared plus 33 times 5 minus 40, which gives 250 minus 375 plus 165 minus 40, which does, in fact, equal 0. So that's part A done. Part B. Express g of x as the product of a linear and a quadratic factor. Well, the fact that g of 5 is equal to 0, that's telling me, from the factor theorem, that x minus 5 is my linear factor. So if I do a little bit of algebraic division here, if I divide my g of x by x minus 5, I should hopefully be able to say what the quadratic factor should be. So x into the 2x cubed goes 2x squared times. We multiply out. 2x squared times x is 2x cubed. 2x squared times the minus 5 is minus 10x squared. And we take that away. 2x cubed, take away 2x cubed is 0. Minus 15x squared minus the 10x squared. So that's going to be a plus 10x squared, gives minus 5x squared. Then we repeat the process. The x into the minus 5x squared goes minus 5x times. And then we multiply back out. So the minus 5 times the x is minus 5x squared. The minus 5 times the minus 5x times the minus 5 is plus 25x. And we take that away. The minus 5x squared minus 5x squared is 0. The 33x take away the 25x is 8x. And then one last time, the x into the 8x goes 8 times. And multiplying back out, the 8 times the x is 8x, the 8 times the minus 5 is minus 40, and you can see when we take those away we get 0 like we expected. So therefore we can rewrite g of x as the product of a linear factor, the x minus 5, and a quadratic factor, the 2x squared minus 5x plus 8. Part C. Hence show that g of x equals 0 has only one root. Okay, well we know it has one root, the 5. We know that 5 is one of the roots. So if 5 is one of the roots, that must, and this only has one root, then that must mean that this quadratic has no roots. So how can I show that this quadratic has no roots? Well, I can consider its discriminant. If b squared minus 4ac is negative, then this equation will have no roots. So let's do that. B squared minus 4ac. The b is minus 5. The a is 2. The c is 8. So we get 25 minus 4 times 2 times 8, which is 64. We get minus 39, which is less than 0. Therefore, the quadratic factor has no roots, so x equals 5 is the only root. So that's part C of this question done. And before I move to part I, let's just refer back to what I said at the beginning of part II with regards to g of x. Remember how I said that g of x was our f of x function just moved down 20 units in the y direction, so that it intersected the y coordinate here at minus 40, and it's passing through the x-axis here at 5. And from this sketch it makes sense why we have only one real root, because we can see that this graph is only intersecting the x-axis in one place when x is 5. So our answers for part II should hopefully make sense. Part III, describe fully the transformation that maps f of x onto g of x. I've been talking about this consistently through this video. It's a translation I could write it in vector form, by 0 minus 20, or I could say translation by 20 units in the negative y direction. I think I'd probably leave mine in vector form as it's a little bit more efficient.